Okay guys, the main difference here is conservation of energy worksheet number 1. The main difference you want to remember is it's the same equation except for now you don't have to deal any work. Works without work, conservation energy says energy before must equal energy after. If it's not, then it equals to work. I just like to always use this equation no matter what. Let's draw us a quick picture, see what's going on here. We got us a ball down here at the bottom, and we're going to throw it up in the air. So it's over here now. Notice when this ball is at the bottom, it has no springs in this problem. It has no height at the very beginning, and then at the very end it stops. Since it's a conservation problem, you have no work. They didn't say anything about any work anyway. So now this becomes very nice and clean. It becomes a very cool problem because it becomes 1/2 mv squared is equal to mgh. If you notice, both sides have m's, cancel them. You now have 1/2 v squared is equal to gh. It says find the maximum height. And now if you switch this around, gh is equal to v squared, because I'm going to put that 2 on the bottom. Whenever you divide by 2, it just becomes a fraction. Now what are we going to divide by? G divided by g, right? Now sometimes people have a hard time dealing with that. So let's come up here and multiply both sides by 2 first, so we can get rid of the fraction. V squared is equal to 2gh. Now when I divide by 2gh, it's very clear that the h is simply v squared over 2g. A while back, some of you guys were trying to use that maximum height equation and had no idea where that max height came from. Here it is. That's where it comes from. So now you know h is equal to, that initial velocity was 35 squared divided by 2 times 9.8, which I get my handy dandy calculator for. I know once again, let's clear this. That becomes 35 squared divided by 19.6, because that's 2 times 9.8. So now that tells me my maximum height is 62.5. Done. Very nice, very powerful, because it's a whole lot easier than trying to do those kinematic equations. Thanks. Love you, bless you.